Well, hello. I'm Rhonda Edwards here with the VMware Open Source Program Office, and I'm here with Stephen Rostedt, and he is an open source engineer at VMware, and he's going to talk to us today about why he became involved with open source software. Welcome, Stephen.
Hi, welcome. Hi again, my name is Steve Rostedt. I'm known as, mostly known for Linux kernel development. I'm the author and creator of ftrace, which is the official tracer of the Linux kernel. I mostly got involved with Linux by working on the real-time operating system, or converting it into a real-time operating system back in 2004. But before that, what got me interested in open source was my drive to always know, how does that work? So whenever I did coding and looked at something, it wasn't good enough that it just worked. I had to know why it worked. So to demonstrate this, I'm going to share my screen and talk about some basic, very, very simple things that people do when you program. So, okay, so hopefully my screen's shared. Anyway, from the common thing, as you see, is the hello world. When people start programming, this is C. Just hello world.c. It was one of the first programs that someone would make. And you do that, you compile it. So I'll just do hello, and you get your hello world. And when someone writes this, they get excited about, wow, I actually wrote some code and it worked. I made the computer print hello world. To me, that wasn't good enough, because what I really did was I called some function called printf, and I want to know, what does that printf do? With open source, it kind of drives that, because it lets you see what's inside of those functions that you call. So instead of just looking at printf, you know, if you want to do something a little bit more special, you could do strace, which is a utility that watches how an application talks to the kernel it's running on. So if I were to run hello world, you see this. It's a bunch of system calls that interact between the user space program and inside into the kernel. Now, for me, I was like, okay, this is kind of cool, because now with strace, you could see the level of what hello world is doing. And some of the things it's called, and there's lots of things in here that's kind of confusing. Like, what's this exec VE? Well, and then there's, you know, all these other functions that it's calling, and it does a lot. You think it's just hello world, but say if you're just interested in actually how do you print something to the screen, it's this final system call called write. Now, one of the reasons why I fell in love with open source is because I was able to look at the code and actually look deep into it. And as I mentioned, I'm the maintainer of ftrace, which is the tracing Linux kernel, and I want to show you a little bit what that gives us. And I kind of wish that ftrace existed when I first started working on the Linux kernel, because I had to actually just look at the code and spend hours and hours searching for things and following things, and I had no idea what I was looking at. I read books and all this stuff, but since Linux kernel is constantly moving, the books were constantly out of date. So what I want to do is see what my computer is actually doing at that moment when I run it. So when I see this write command, what I created was ftrace, which the front end is called trace command, or trace cmd. So if I were to, I have to be root, so luckily I switched user into root before. So if I run trace command on this function, if let's just trace all system calls. So I'm going to record, let's say, system calls, and on this hello world. And I'm going to do #F to follow it. And when I run this, it's going to enable it, run hello world, and then it's going to record all the things that happen within the kernel. And inside there, you'll see those basically same functions that are called within the kernel. Again, when I wrote printf in the C kernel, I said to myself, okay, this is interesting, this is great, but how does printf work? And then you want to look into the library, so libc. And it's kind of interesting, because my first open source code that I ever submitted to was actually GTK, which is the GIMP toolkit, which does graphic, or the GIMP utility, which is a drawing utility. It allows you to draw applications in Windows. And not just, that was the front interface, but I want to know how that works. So actually I looked at the code on how it works, how it interacts with the X Windows systems, how it interacts with Linux. And all this was done just so I could see how things worked all the way down to the machines. And then when I got to the level of actually watching what the hardware did, I was like, okay, that's good enough. That's too much information anyway. But what open source allows you is not only to be able to see what you're doing, but also modify it, to change it. And I always said that that's a great amount of power. So I always like to say that when you use like a open source operating system, you own the machine. The machine doesn't own you. When you run a proprietary operating system that you can't modify, it's what you got. It's packaged. You got that machine. The operating system does whatever you want, but your interface is at the operating system level. But when you have open source and you can modify the code and make changes to it, you now own that operating system down all the way to the hardware. So unless you're going to modify the hardware, you now have full control of whatever that hardware can do and extend it. For here, I wanted to see what happens inside that write system call. So if I want to do trace command record, and then I'm going to say function graph, and I'm going to graph, let's see if it's, gotta find the system call that does that. Yes, let's see, where's sys read. It takes a little bit when I do double tab because it looks at all the functions in there. No. And here, let's search for it this way. I'm going to search for all the functions inside the Linux kernel that has the word write in it. Okay, let's now grep for the syscalls for that. And you'll see the ones up here somewhere. It's an underscore thing. So don't worry, I know how to do this, so let's cheat. Instead of doing it this way, let's just do trace command, record, -p, function, graph, and let's just search for, or we're going to graph everything that has write in it. Let's see if this works. And do the same thing on my hello world. Now, I actually could see what actually that write system call does and follow it through. It does a lot, as you can see. And then from here, I go look into all this code that it goes through and see if I can find anything. There's all the system calls. Now I can actually pull up the Linux system source code and then follow this along and learn how an operating system works. So open source gives you the ability of learning. And I can't think if it comes down to what is my scratch that I like, that drew me to open source. It was the fact that I could constantly learn from what open source is. And that is basically what I want to explain. And I've given talks on this before. You could search me on YouTube. If you search my name, I gave one that talks about the hello world, from how it looks from the binary code all the way down into the kernel and all the way to how you print it, which goes into much more detail than I could do in a few more minutes here. And if you can, I'm sure we'll probably have links for that talk somewhere and see that. I guess that's all I have to say today.
Well, thank you, Stephen. You know, one of the things that I would characterize you, is that you have this sort of insatiable analytic curiosity. So do you think that's something that you had your entire life? So were you that kid sort of, you know, pulling the tubes out of the back of the television in the garage and kind of tracing things to how they sort of, were you pulling apart the engine under the hood? Were you, you know, taking apart the watch? What, you know, what was that something that came all the way through your childhood? Because you're definitely taking the cover off, right? And digging much deeper into the kernel than I think most other people. So where did this come from?
Oh, that's a good question. Actually, my brother, who actually is a nurse, was probably more so like that than I was. He used to always take apart things. I get upset because all my toys would be taken apart and you could never put them back to make them work again. So he always used my toys to tinker with it. I guess maybe I've always wondered, like, you know, I've always had a curiosity on how things work. You know, when you have something as simple as, you know, a cup, like a coffee mug, I look at how is that coffee mug made? I constantly think, where did it come from? Where did it come from in the ground? I mean, how did the ceramic get made? I always had that curiosity of knowing how things are done. And when it came to the computer, I also had the same ideas, like, how does this actually work? And yes, I guess the answer is that I've always had little um, curiosity into how things are made, how things work, and that did drive a lot of my development in the open source world and in the kernel specifically.
Yeah. Well, great. Well, thank you very much for sharing this. I think everyone can go out there to Google and certainly search on Stephen Rostedt and look at a lot of your other presentations. And we appreciate you being here today. Thank you.
You're welcome. Thank you.